All right, let me go ahead and just kind of briefly go back through pressure-based ventilation. Some of this is a little bit of an older lecture that probably I could delete, but I don't think it ever hurts to continue to go through this. All right, pressure control is a mandatory breath that is pressure-oriented. So it is indeed pressure-based ventilation. And as with all pressure-based ventilation, the pressure is the control variable. It's also the limiting value in the sense that I rise to a target pressure, but it doesn't end the breath. Something else ends the breath. And that something else is time. So I have an inspiratory time and an inspiratory pressure, are the two values that I end up setting. What will determine the volume that the patient receives will be their lung compliance and airway resistance. There's going to be a variable tidal volume and as such a variable flow. And as far as baseline is concerned, you can have whatever you want to end up having. So far, so good? Yes, Harleen.
What happens when the certain pressure is reached? It stops. And then the other
What stops?
When the threshold pressure, when we reach a threshold, then the pressure stops. But the breathing
Pressure is maintained.
Okay. And then
Because when I reached this target pressure, did it stop? It stayed at that pressure.
so but it's still say if it's 30 centimeters. It reached the 30 centimeters and it stays there, but it's not stopped.
But the gas flow does not stop.
Okay.
The inspiratory phase does not end. The hitting that pressure is not the cycling mechanism.
Okay. So the patient is still getting, but it's not getting above 30 centimeters.
It won't go above that pressure. That is correct.
Okay. And when it reaches 1 second, if it's that's the inspiratory time, then it will shut off.
Then expiration begins. Does that make sense? Speak the language. Hola, buenos dias. So I can have, again, continuous mandatory ventilation. I can have with pressure-based breath. I can have SIMV with pressure-based breath. I can actually even have the dual mode with a pressure-based breath. In the case of SIMV, my mandatory breath can be those pressure control breaths. And my spontaneous breaths can be supported with pressure support. Both of these are pressure-based breaths. The difference between them in pressure control, what determines the end is inspiratory time. In pressure support, it's when the peak inspiratory flow falls to a preset threshold, usually 25%. So they're both pressure-based breaths, both pressure-limited breaths. The difference being is what's the cycling mechanism? Is it ending because an inspiratory time has elapsed? Or is it ending because the inspiratory flow has slowed down to a preset point? Very subtle difference. But they're both pressure-based breaths, and by definition then, tidal volume and flow rate are variable. Clear as mud? Just about. Okay, good. I added this part in. I don't think you have it on yours. Technically, it's not a decelerating ramp. It's really what's called the exponential decay, and the way I always draw it is as such. It's not, when you talk about a ramp like we would have in volume-based ventilation, it's fixed. Every single breath looks the same. And pressure-based breaths and pressure control, pressure support, that's going to vary because it's patient-dependent. Whatever the patient wants. You want more flow? Take more flow. You don't need as much? Okay. Because pressure-based breaths have variable flow rates, determined by the patient. And literally, If you look at a tracing, everyone's going to be a little bit different. Kind of hard to see this, but let me see if I can make logic out of this. Here's a square wave. This is flow. This is pressure, and this is volume. This is a volume-based breath. I'm fixing the volume. Every breath is exactly the same. Same tidal volume involved. Same flow rate involved. What has changed is the peak delivery pressure. And the reason why it changed is because I changed the resistance within the circuitry. I've made it now so my resistance is increased, bronchospasm, and the peak pressure went up. What didn't change is the volume or the flow.
So this is what would happen if there was bronchospasm.
Yep. Yep. Same thing would happen if I had a fall in compliance. Something that made the lungs stiffer would require more pressure to push the same amount of volume in. If I'm seems like I'm repeating myself, I am. Usually about the 75th time I say it, it's like, oh, now I get it. So it is purposeful. That's volume-based ventilation. In pressure-based ventilation, it's my pressure curve that is fixed. And no matter what happens, the pressure stays the same. Well, there is some shape to it there. The way that I always draw it is truly as a square, but we can taper that. We can fiddle with that, and that'll be the fall.
But the same thing.
Same general idea. I rise to my target pressure and I stay there for an inspiratory time. Now, if you'll notice, this volume is not the same as this volume, which is not the same as this volume. So something must have changed going from here to here, or going from here to here. What would change? Resistance or compliance. What happened here is that I have a bigger tidal volume than I did here. So what could have happened? Compliance could have increased. It's now easier to get volume in than it was before. The same pressure now is delivering a bigger tidal volume. Or airway resistance went down. Come on. Going from here from A to C, the exact opposite. Compliance fell, resistance went up. Both of them will yield this kind of similar picture. In pressure-based ventilation, pressure is constant. The amount of volume and flow is dependent upon the compliance and the resistance. I'm tired. Let's go home. My brain hurts. So what's the good news about pressure control? Why is it that I was mentioning earlier, 20 years ago, everybody was volume ventilated in the adult world. Is that fair? And pretty much everybody in the neonatal world was ventilated with pressure. Now, we've flipped. Pretty much everybody neonatal ventilation is becoming very much more volume oriented. In the ICU, we're being much more pressure oriented. 10 years from now, it'll probably flip back again, so who knows what'll end up happening. Good news about pressure-based ventilation, why a lot of people really, really like it. It's because there's no flow starvation. Flow is variable. You want more flow, take more flow. Go ahead. And in a lot of patients, it becomes very uncomfortable being told how much flow you will have. Okay? They'll tell you, I don't feel like I'm getting a full breath And you're thinking, oh, well, the volume must be the wrong volume. It's really the peak flow rate. They're not in control of it. Because I'm limiting the pressure, but theoretically at least, there's less barrel trauma. Less fear of having excessive pressures being applied. Actually, it's another advantage I don't have there, and that has to do with better gas distribution throughout the lung. At the end of the inspiratory phase, remember we said you had this rise in flow initially, and then as it fills the lungs, it slows down. Well, that ending portion helps disseminate gas to the periphery. Disadvantages, I don't know so much therapists anymore, but certainly a lot of docs, especially the older docs, they didn't learn that way. So when things go wrong, they're not comfortable with how to make changes. So, do you think it's still pretty true?
I disagree with you on this one.
Do you?
Yeah, because I don't think we use pressure control ventilation as much as we use dual mode, and I don't think people still understand dual mode.
Oh, good point there. Yeah, you're right there. And they don't understand.
I think we're using volume control.
Yeah, I know.
So I have to disagree with you on this.
Okay. Well, therapists and docs not as familiar, so we are true.
True.
We are correct then. Okay.
Yeah, very, very
And again, you need to monitor the volume because that's going to become the variable. If our goal for mechanical ventilation is alveolar ventilation, and there's changes in compliance resistance, and we're not accomplishing that, we're failing in our job. Okay. And we talked about this. As compliance decreases, tidal volume will decrease. If compliance increases, tidal volume will become bigger. So you need to monitor that kind of stuff. Because I'm fixing the pressure, I can't really get a plateau pressure in pressure control by definition. The only time you can is if I'm monitoring my pressure and I'm looking at the inspiratory flow and there's a period where there's a plateau before the beginning of exhalation. That pressure and the volume that is attained can be a surrogate for lung compliance. Okay, and we'll demonstrate that on a couple of the ventilators. All right. This is flow rate, correct? Can you agree with me that this area under the curve, don't just love math, is volume? Flow per unit time, sum it all up, you have tidal volume. So the size of that is the tidal volume. And this graph isn't really drawn correctly because in theory, what goes in should come out. And those two areas don't look the same. So in pressure control ventilation, there's a certain pressure that's going to generate a certain tidal volume based upon compliance and resistance characteristics. Now notice what happens if I lengthen the inspiratory time. There's this part right over here that's cut off. So when setting up pressure control, it's important not only to set the peak inspiratory pressure, but to set an appropriate inspiratory time. Let's say that this tidal volume that was attained here was 400 milliliters. And 400 was kind of small. I'd like to get a bigger tidal volume. I could go up on my pressure to get a bigger tidal volume, but I can get the same output just by lengthening the inspiratory time and allowing that to come back to baseline. I can get this up to 550 simply by lengthening eye time.
Would you have to change frequency also when you do that?
You wouldn't necessarily need to change frequency. You just need to be aware of the fact that as I'm lengthening eye time, I'm shortening E time. And if the E time is inadequate, then I may need to look at doing something with frequency. Because potential for air trapping happens. the reason why I point this out is because I may not want to go up on my pressure. It may be a point where it's like, I really don't want to go up any higher. So when setting this up, I set not only the pressure, but I also make sure that my eye time is an appropriate eye time. What I used to do is basically, Doc would give me the order for what pressure he wants to start at. And I'd say, well, hold off on telling me or figuring out what the inspiratory time is. Let me optimize that to get the best volume for that.
And I forgot, how do we tell if we're air trapping on the bed? Is there something besides
Next week.
next week, okay?
Oh, I was gonna say, this might be silly, but you know how you said proportionately the volume going in is the volume going out?
Should be.
So if you've seen that, would that indicate that you're air trapping because the volume's not coming out?
Can you hold that thought till next week?
Let's hold it.
Yes and no.
But then my question was gonna be more to what you just said about the inspiratory time and whatnot. That's kind of what we did with IPPB, right?
Mm-hmm.
You just played around with it until it was comfortable.
Mm-hmm. Yepper. So again, PCO2, if my PCO2 is too high, I can check the rate, adjust that, go up on the rate, lower the minute volume. Excuse me. Go up on the rate, raise the minute volume. Same would be true by getting a bigger tidal volume by pushing the pressure up. Is that still true? Looking at plateau pressure to set the... Yeah. If you're in volume-based ventilation to start with, and you measure the plateau pressure as 25, it's an argument to start your peak inspiratory pressure at 25. Okay, it's what a lot of places will end up doing. So how do I increase tidal volume? Well, I go ahead and make sure the eye time is optimal. I'm getting the full bang for my buck, and then going up on the pressure limit. This should not be anything foreign to you, calculating inspiratory and expiratory times. We've been through this 1,000. Okay, it is foreign to you, but we've been through this before. Total cycle time is nothing more than the rate divided into 60. And then if you know what your IDE ratio is, 1 to 3, add those two together, would be 4 divided by my cycle time, and you can get what your inspiratory time is, and then subtract that time from your total cycle time to get E time. So here's total cycle time of at a rate of 20, and an IE ratio of 1 to 2. I have 3 seconds. Add my 1 and 2 together to get 3. And then you just 3 divided by 3 is 1, so inspiratory time is 1 second. 3 minus 1 is 2 for 2 seconds. And this is just kind of this is just rearranging the first equation, substituting frequency for I plus E. This is an example where you end up having, you put the larger number on top and the smaller one on the bottom. So here I have an I time of 1 second, E time of 3 seconds. What's the IE ratio? It's the 3 over the 1 or 3, and that's always 1 to whatever we're solving for. So in this case, it's 1. It's a 1 to 3 ratio. Now there is something called inverse ratio ventilation, where purposefully I create an inspiratory time that's longer than an expiratory time. And if you think about it, that's got to be damn uncomfortable. And it is. And that's why we often will have to control these patients when they're in this kind of approach to ventilation. We primarily do it to improve oxygenation in patients that are shunting tremendously. Okay? We actually create air trapping. I mean, we'll learn that air trapping is bad. auto peeps bad. Well, not in these patients. And the biggest problem is that long inspiratory phase prevents blood from returning to the heart, and you can end up having some pretty nasty cardiovascular problems. That's kind of straightforward questions. So, by the end of this course, mid-July, you're going to know how to process the ventilator, how to clean it, how to put it back together, check it out, put the appropriate humidification device, and assist control, volume control is all I'm going to focus with. Now, I say that, and let me add on to that on 2 of the ventilators there'll be dual control. Because conventionally in the real world, we don't use volume control, assist control with the Draeger or with the Servo I. Although they have it, you don't want to use it. It's mean. Huh? Well, that's a whole separate issue. In the fall, Mary's going to talk about liberation from ventilation. She's going to get more into waveform and graphics and how to know, just by looking at a picture, that I got the right settings. Teresa, nod your head yes. There we go. Very good. And then we'll get into some really bizarre stuff. Some of the newer stuff that's on the cutting edge that when I got the worst possible patients to ventilate, how do I ventilate them? How do I use high frequency? Etc. So, again, there's that one lab that looks on all 3 ventilators to kind of walk through it. Then check 171. See if that's that lab or not. It should have a list of settings across the top. No? Page 169. You can see on top there's some settings that are there. What you should be able to do is get comfortable plugging those settings into each of the 3 ventilators. Some of those settings are spontaneous modes, so you'll need to have one of the test lungs that will actually, act like a spontaneously breathing patient. Does that make any sense? How about if I walk through them with you? And then the 3 PEs will end up being there. You'll be able to get to. There we go. Tuesday and Thursday you're here. Monday, well, depending upon the clinical site, it could be Monday, Wednesday. It could be Monday, Wednesday, every other Friday. It could be Wednesday, Friday. It varies. Tuesday and Thursday you're in class. For the whole fall semester and for the following winter semester. Yeah.
For all classes? Mary's too?
Uh-huh. All didactic classes are on Tuesday and Thursday. And the clinicals depends upon the site, what days you're there.
How many clinical days are they using, 2 or 3?
It depends. Yeah. Yeah. The peds rotations are 16 hours per week, so it's 2 days, two 8-hour days. The adult clinical rotations are 20 hours a week, so that could be 2 10s, a 12 and an 8, every other Friday, 8 hours. Depends. Okay?